Great. Welcome everyone. My name is Flo. We're gonna start. So I'm the corporate innovation manager for the US branch of True Paris region. I'll be your host today for our tech meeting dedicated to new materials. This session will be recorded and shared. So please let me know if anyone would be against it. So we're gonna start with the agenda for today. So after a short introduction of what we do at True Paris region, I'll provide some key figures about the materials industry. Then we will move to the fireside chat with our experts, Ben Price and KP Reddy, to discuss the industry and tomorrow's big trends of innovation. We will finish this webinar with a selection of innovative companies presenting their solutions and products. We'll answer questions at the end of the fireside chat if you have any, and you can react or ask some questions. Great, so we're going to start, and I'm going to jump into it with a short presentation of True Paris region and what we do. For some of you who don't know us, True Paris region is a catalyst for business and innovation. We partner with Fortune 500 corporations in order to support in international companies. So we partner with those companies willing to expand and set up business in the Paris region. So thanks to our presence and vibrant tech ecosystem located in San Francisco, New York, Beijing, Shanghai, and of course Paris, we are in touch with over 4,000 international companies every year. So this unique relationship with large corporations on one hand and with innovative, fast-growing companies on the other hand, led us to create the Global Open Innovation Network about 5 years ago. Oh, sorry, someone is touching. Great. So yeah. Through this global program, we organize about 20 events a year to foster business and technology partnerships between large corporations and startups. Since the pandemic moved our events online, it allowed us to connect with more people, more companies. So it has been a pretty interesting experience. We cover an era of technologies and topics. So as you can see here, we have like mobility, we have AI, retail, health, you have logistics, smart cities, and you name it. So today we're going to talk about new materials. So first, I wanted to show you a very brief overview of the material industry. Of course, it's composed of different actors from various industries. So as you can see here, it's ExxonMobil, it's Schlumberger, Saint-Gobain, but we can also find a lot of actors in clothing, for example, or science, and so that we'll have some examples actually during the startup presentations. So here are some key figures I wanted to share today. I wanted to stop on 3 main figures really quickly to set up the base of our discussion with the panel. So today, the first one is today the global material market size is valued around like $190 billion based on a PwC report. The second thing, something really important as well, is that by 2030, the revenue forecast is expected to reach $330 billion. And the last one I wanted to share today is the compound annual growth rate for the materials industry is expected to be around 5.8% from 2021 to 2028. So those trends and industries where new materials are like a prominent trend today, as we can see here, it's the construction industry, it's in science, informatics, clothing, etc., etc. So to finish this overview of the material industry, I wanted to share this non-exhaustive market map with you. We designed it based on different players we have identified on the market. It's missing a few actors, of course, but it gives us a good understanding of on what's happening these days in the market. So yeah, great. So I don't want to take I don't want to get into too much details. So if you're interested or have a question, feel free to reach out to me. I'd be glad to share with you or tell you how I built it. So without further ado, I'm going to invite our two experts today for the fireside chat. So Ben, KP, if you can join me on stage. Hello. And Ben, yes, perfect, great. Great. Thank you for accepting my invitation and being with us today. I'm very excited to have you to discuss the different topics. So maybe first of all, and to give some context, maybe you could present yourself, tell us a little bit about you, the organization you're representing, and your maybe like current projects or initiatives. KP, maybe you wanna start?
Yeah, sure. Thanks for having me. It's always fun to do these events. So my background, actually, I'm a second generation civil engineer. So grew up writing code as a kid, and then from then being on construction job sites. So that 28 years of experience, we started Shadow Ventures about 3 years ago. So we're a venture capital firm focused on construction technologies and real estate technologies. So that's what mostly what we focus on. I would say we do software, we do hardware. We're now, I would say, looking at the intersection of materials and hardware and how those intersect. And we're starting to build kind of a pretty strong thesis around how materials fits into, call it the construction process and actual buildings in general, right? So how does it fit into buildings in general, which we think there's actually more innovative materials sitting in warehouses than they are, opportunities. So there's plenty of opportunity. There's just we haven't been able to get innovative materials to the job site, to the buildings as fast as we could have.
Great. Thank you for being here. Benny, you wanna go next?
Yeah, thanks a lot, Flo, and thanks, KP. It's great to be participating in this with you. But my name is Ben Price. I'm on the Nova External Ventures team for Saint-Gobain, and Saint-Gobain is the largest building materials manufacturer in the world. And the Nova team invests in and looks for partnerships with startup companies on behalf of the various businesses across the Saint-Gobain group. And so my personal focus is all things building materials and construction processes, but I have colleagues on the team that are focused in our other industries, kind of more broad, including mobility, life sciences, so spanning beyond buildings and building materials. But really excited to talk about new materials, our focus on sustainability, and some of the themes that we're seeing. We've had a lot of recent activity, investments, partnerships. So I think it's a really exciting time to be looking at construction tech, prop tech in general, and all of the innovations that we see coming.
Yeah, definitely. Thank you so much for being here. I agree with you. It's going super fast these years. So great. Yes. So maybe we're gonna start with my first question for you. Very general question, actually. We just saw that like materials is a very wide subject that could be found in various different topics or various different industries. So I first wanted to ask you this: what is a material or like a new material company today? Ben, what's your opinion on that?
Yeah. So it's a good question, and I think there's a lot more focus on innovation and kind of forward sustainability and forward looking side of it than traditionally, which is great. where I think traditionally it's just how much of a material can you produce and how quickly, and then innovations or the focus started to be how do you make something a little bit faster, a little bit cheaper, but we look at a wide range of sustainability, product improvements, cutting down on costs, cutting down on materials, cutting down on time. And we also are starting to span into looking further downstream. And so how are these materials being used? How can we have a role in helping that process? Everything from supply chain through the actual installation, through a full kind of life cycle assessment of a lot of the materials that we produce, and what does it look like after when we're recycling or finishing with use of the materials. And so I guess to answer that concisely, I would just say it's a lot broader than kind of purely manufacturing and output, that there's a lot of innovation and technology that companies like Saint-Gobain are looking into.
Yeah, definitely. KP, do you have like another definition maybe? Do you agree?
Yeah. I think the way I look at materials is, and it's, once again, I'm focused on buildings, right? I'm focused on that. That's what I'm focused on. There's two types of materials, right? There's two things that go into a building, and that is primitive materials and products. And those primitive materials and products are assembled by people, and today people mostly, and then in the future people and robots, right? So that's kind of how we look at it. If you look at primitive materials, that's soil, that's concrete. I would say it's the things that go into a building that don't have a SKU number. It's tonnage, cubic yards, it's unitized. And so are you going to innovate soil? Maybe. There is additives to soil. There is soil concrete. There are things that you can do with primitive materials. If we look at concrete, which there's a lot of focus on concrete and carbon sequestration and all those things, are there things you can do with concrete, or do you just get rid of concrete? Do we stop even thinking about concrete? Same thing with steel, right? But so there's definitely innovation happening there. Then if you look at the products, which products I define as they have a SKU number, right? They are windows and doors and doorknobs and flooring. So if you look at that, a lot of the innovation around materials there is happening in a factory. It's happening in a factory somewhere. And clearly we see innovation happening there. But a lot of even those materials are highly dependent on non-man-made materials. So I think what we look at is we look at those as the two lanes of how do you innovate primitives and how do you innovate products as it relates to construction. And we think either place there's massive opportunity.
Yeah, definitely. So one question actually, because you're talking about innovation in construction. Why do construction companies and leaders always ask for those innovations? What are the reason behind that, on always like innovate in those areas of materials?
I don't think they do. And that's the problem, right? The problem is you have an industry that was founded at the beginning of time that continues to use materials that maybe were found at the beginning of time, right? It's nothing, there hasn't been a lot of movement in how people think about innovation. And if the industry was left alone, nothing would change. The only reason they're changing now has to do more with external forces, whether it's focus on sustainability, whether it's supply chain challenges, whether it's labor challenges. If left alone, the industry would not change at all. They would just keep doing things the same way that they're doing things, because that's how their father did it. That's how their grandfather did it. That's how their great grandfather did it, right? There's no reason to change, right? So I think what's happening is you have this perfect storm brewing where you have material shortage, labor shortage, and you have a customer that actually cares. You know, if you are building a building for Salesforce, their chief sustainability officer actually cares about what is going into the building and what materials are being used. I can't say that 20 years ago that most companies actually cared. They cared if they got the little LEED certification, which is easy to do. You don't actually have to do anything innovative to get the LEED certification. So they cared about the marketing of sustainability, but they didn't care about the results and actualities of sustainability. So I think that behavior is pushing the industry, kicking and screaming to be innovative.
Okay, got it.
I'd agree with that. Just to add that, I mean, you can insert every version of that McKinsey slide of lack of improvements in productivity in the construction industry, but I think it is there's regulation on one hand, then there's kind of impact and what companies are doing to make improvements, and one example of that, and a lot of this is reflected in our manufacturing processes, but Saint-Gobain pledging by 2050 to be carbon net zero. And so I think as more companies like that make those pledges, it's driving demand, and the manufacturers need to keep up with that and need to keep innovating their products to fit that, and to enable the types of buildings, the healthy buildings and sustainable buildings that people are demanding.
Right. Yeah. Actually, on that, some reports stating actually that the industry, the materials industry, has not been like performing too well over the past years, even before pandemic time, and so construction is the biggest industry in the world, and yet even outside of crisis, it is not performing well in terms of numbers. So what's your thought on that, Ben? Maybe.
Yeah, I think it's very much top of mind right now, the shortages, and I guess I look at it from the perspective of innovation and the investment arm of Saint-Gobain, and it's I guess you could say that's why our group has a job, and there's reliance on what we're doing, and kind of trying to drive improvements and work with other companies. And so that's kind of what we're tasked with is, how do we make something more sustainable, better performing, and easier to ship, easier to install and work with, to help our customers, to help our processes and boost our margins and boost our output across all of our categories. So I think as more and more attention and kind of focuses on this, and as it, particularly now as material shortages are top of mind for everyone, it becomes that much more of a priority.
Yeah. Mm-hmm. I think you also have this interesting dichotomy around new materials or any kind of new idea. We met with a company that's taking unrecyclable plastic and turning it into aggregate for use in concrete, right? So we can all agree there's a lot of plastic waste, right? There is no shortage of plastic waste. We can all agree on that. We can agree that concrete manufacturers need more aggregate, right? So we see this. But when you ask the company, how do you get there? Like, how do you grow? They say the challenge is the big projects. They want 1 million tons next year. I can do 100 tons next year. So the challenge with the scaling up of new material, any kind of company focused on new materials, even when you have efficacy in the material, when you have two willing parties, you have feedstock here, you have demand here, this middle part of how do you scale up to actually serve a project is really, really difficult. When I was studying graphene and looking at graphene in construction, it was never an issue. Are there use cases? Are there opportunities? It was always like supply, So I think one of the challenges you have is some of these folks with new materials, they look at markets like construction and the requirement of scale is so fast and so big that they tend to go focus on another thing. So like this company, they said, well, we're trying to concrete people, but they want too much. So instead, we're going to sell bags of this on Amazon for people to use in landscaping. Right. And it's like, well, that's not that exciting. I'm more excited about this thing, right? Not the small thing. And so I think that's one of those ongoing challenges of when you have new materials coming as it relates to construction, how do you scale fast? Because you're competing with something so cheap, so available, that it's very difficult.
Right. Yeah. And that's exactly what I wanted to ask you actually, is about the different prices, because how, like new materials have like higher prices because they using usually like advanced materials, and so how would you say it's affecting the industry, since prices are higher for those materials compared to traditional ones?
I think in a lot of cases, the incremental cost is not that much, right? If you think about a building and what is expensive in a building, right? HVAC systems are very expensive, right? When you look at concrete and the cost of aggregate, it's relatively not that expensive. And I think what, the cycle we're in right now has very little to do with cost, quite honestly. It has to do with availability. When we work with a lot of large building product manufacturers around innovation strategy. And one thing that's very clear in our research is the market doesn't ask how much, they ask when. If you have this new material, how much do you have available and when can you get it? And then let's talk about price. And that's this cycle. What I'm saying, in 5 years, it might be, I need the cheapest thing possible. Like, this industry is cyclical and we move from high, lack of availability and prices, and, it shifts to high availability and low prices. And that's what it does. So I think we're in a cycle right now where price isn't that important. And there's certain areas where the incremental cost of something isn't that big of a deal to the relative cost of the entire project. And we're also in an interest rate environment where money is so cheap that if I'm financing it, which everyone finances, how does it affect me? If I can say on a monthly basis, my net carbon output is lower, with a new product, once I finance it at 2.5% interest over 50 years or whatever, it pays for itself pretty easily. So I think, we have a low interest rate environment that makes the ROIs easier in terms of payback. And we also have a lack of availability of, so I don't think price is that big of a driver these days. That changes, right? In 5 years, it might be all that anyone cares about is price.
Yeah.
And I think that's reflected through, I would say, kind of through the objectives of companies like Saint-Gobain, manufacturers that are trying to get involved further down the value chain, where, if we were traditionally purely manufacturing materials that could be seen as a commodity, the focus is, there's an increased focus on how to demonstrate the added value and really kind of connect with the end building inhabitants, but also the architects, the developers who are choosing which materials.
Okay, makes sense. Yeah, so you both work with startups or like with innovative companies. So definitely a question about innovation. What's the biggest innovation, or what's the innovation you've come across those past years? Ben, yeah, you wanna tell us a little bit about what you see at Nova?
Yeah. So I guess I'd break it down into a few buckets. We'll say, so to group this into 5 areas. One would be on recycling, and so on kind of what inputs or new inputs are there that we can then use, recycled material we can then use to manufacture. The next one would be during our actual manufacturing processes, and what technology, whether it's materials themselves or robotics or automation, can we use in that process. The third would be once we've produced our materials, more focused on the supply chain and bridging the gap between us and the job site. And then the fourth would be the actual materials themselves, developing better performance, lower footprint, carbon sequestering materials in general. And then the fifth, and I think I mentioned this, was the focus on end of life cycle and basically approaching materials through an LCA lens, looking at the total kind of implications of their production and use.
Okay, makes sense. KP, do you see anything?
Yeah, so we break things down into 3 buckets because we're engineers. So we look at design, construction, and manage as the 3 buckets in terms of the life cycle of how you think about a building. On the design side, what we're starting to see is the advent and use of AI and technology that really helps a designer execute on the iterations, right? The challenge is an architect or an engineer sits down, they are biased to implementing a design that they are already familiar with. That is their bias. They are risk averse. This is what we did on the last 3 hotels. This is what I'm going to do on the 4th hotel. So being able to insert innovation, whether it's materials or anything, you're dealing with this inertia of doing the same thing. So we're starting to see technology that really allows them to run 1 million simulations. If you think about a building, it is like an ecosystem. And every variable in that ecosystem shifts based on the others. And it's very hard for a human to drive 1.5 million design iterations. It's impossible. So what we do is we pattern recognize to the 2 or 3 options that we know and are comfortable, and then we do those things. So we're seeing a lot of innovation around how you think about configuration, iteration of design, and running massive, massive simulations on the design side to come up with the right answer, right? What I would say is currently the design industry focuses on this idea of like, there's lots of right answers, which is, to me, is kind of a lazy response. There's lots of right answers, right? I think when you think about computational design and if you think about theory around that, there's actually one right answer. The problem is a human can't get to that one answer, a computer can. So we're seeing trends there. On construction, whether it is the full automation or semi-automation of construction, which is massive as it relates to materials, because, when 30 years ago, I was working with a company that did aerated concrete, very innovative, very interesting, built a factory. When they sent it to the job site, the labor force didn't know how to work with it. I've never seen this before. I don't know how to use it. I don't know how to do it. And they ended up shutting the company down because the people on the ground still want to swing a hammer, still want to use a drill. That is their skills that they have. And when the material shows up and they can't use those skills, they don't know what to do. So they resist change. So what we're seeing is materials being able to come to the job site because of full automation or semi-automation and being able to be implemented very well. We have an investment in a company called Icon 3D. They do 3D printed houses. There are no construction workers. There's an operator that pushes buttons on an iPad, but outside of that, there is no one else on the job site. There is no one else to convince. So when I load that 3D printer, I can load it with lots of materials. I think one of our panelists is in the graphene world. If he says, oh, I have this great graphene material, I'm like, great, let's put it into the 3D printer and see what happens, right? Or I have this other recycled material, plastic. Let's put it in, let's see what happens. Computers and machines do not resist change, people do. So we're really tracking that on the job site. Then when you look at managing a building, if I tried to sell you a car tomorrow and I told you I can't tell you how much it costs to maintain it, I can't tell you what the gas mileage is, essentially if I'm selling you a Jaguar, like that's what you're buying in a building is, and I think that's a problem too, is that people are managing buildings without actually knowing what the cost and impact of that building is for the next 30 to 50 years. And unfortunately, we live in a society now where we throw, the new iPhone came out yesterday. We're all throwing away our old iPhones out by the end of the year. We don't care, right? Unfortunately, buildings, we don't get to throw them out every September. Unlike what Apple tells us to do, we have to live with it for 30, 50, 100 years maybe. And so really understanding technology of how you manage and operate these buildings, how do you retrofit, and what is the cradle to cradle methodology around the building?
Nice. Yeah, definitely. Great. So Ben, you mentioned that recycling materials, or like recycling in general, was a big trend. Definitely know that like the three main innovation in new materials, which was like the sustainable, smart, and responsive. Just wanted to ask you, like, do you see a large amount of startups being created in that space? Like, how's the industry doing in terms of like innovation in those three main IDs?
We definitely do, and we're always excited to see more. And it's kind of, as you look across our product lines and our business units, the groups are always interested to meet with startups that have new approaches, are using different materials. I think, I mean, one example that I love to share is just the other inputs or materials to replace traditional cement. And we've seen everything from plastic to using mushrooms to using kind of a completely wide array of things. And so I think that's really exciting, and it's Saint-Gobain and corporations, I think, benefit quite a bit from entertaining these new kind of out of the box ideas that are very different from the 300 plus years of manufacturing for building materials. Mm-hmm. And so I think that's a major theme, and companies like us being open to those and wanting to work with those companies. The other side, that's on the hardware side. The other side is, and as KP mentioned, the adoption and reliance on software to push these initiatives forward, to sell the value proposition, and to help our customers kind of understand the benefits and the options when looking at materials. So we've also had a number of investments, partnerships, talking to a wide array of companies around that, the metrics and the software side of things.
Mm-hmm. KP, yeah. Do you see any like new entrants like really disrupting the market? Like, do you have any?
Yeah, I mean, I think we see a lot, right? I talk to 10 startups a week. That's every Tuesday. Typically, I talk to 10 startups. That's what I do. I interview them for investment. And I think one of the things that we continue to see is a lot of innovation happening. But unfortunately, one thing about our industry that's very different than most, it is still very hyper-local. So you can't market globally. If you're Dropbox, you can market globally overnight and no one cares. Our industry is very much show me the project you use this on, and it better be within a drivable distance. And so you have to create momentum. So if you think about customers and market segmentation, I think in our world with tech, we might be one of the only industries left where we have to think about geography. So geography is a variable. And so one of the challenges is you see innovation happening in, maybe New York that someone in Omaha doesn't know about. Or maybe there's innovation, even in India, there's a company in India that's doing hemp concrete. It's very fascinating. But this guy's in Nepal, in the foot of the Himalayas or something. I don't know how to go see his project, right? So it's insane. But so I think that localization is a challenge. And unfortunately, what happens is a lot of the large players a lot of the large materials people, they have that advantage of distribution because physical distribution still matters versus, software where it just goes anywhere, like no one cares. So I think that's going to be an ongoing challenge. And we're starting to see that with modular construction's a good example. There are not international modular players. There's 3 companies in New York, 3 companies in Southern California, 5 companies in Northern California. Like that's just what it is. So that fragmentation around geography, it's a challenge, but it's also a pretty interesting opportunity. And I think you're starting to see some of the larger companies starting to identify the disruption that could happen there.
Mm-hmm. It's the case.
I think that's I was going to say it's a perfect. I think modular or prefab or offsite is a perfect example of that, and that's our approach has been very, very regional, and we've invested across multiple companies and are partnering across multiple companies, but it's very regionally focused. So I think that's a great example.
Yeah, and I will say something that the pandemic and the supply chain, I think, America gets very insular, like, what are we doing? China's messing up our supply chain, so now we're going to build everything here. Or Taiwan has all the chips. What are we going to do? We need to build more foundries here. So that's a very American way of thinking. But the reality is, I think globally, everyone's realizing if I can create local manufacturing and as much as possible use hyperlocal resources, why am I shipping something across the planet? Right? Why am I doing that? Because the technology exists for us to create highly scaled down manufacturing that's highly distributed and can exist to serve that market. We see that a lot of times, in concrete. Concrete's a good example. If there's a big enough project, they put a concrete plant on site. They don't take it from from 50 miles away. So I think what you're starting to see too is that the advent of being able to do highly microcell manufacturing, it doesn't have to be this hub and spoke manufacturing and distribution system. We can actually bring manufacturing much closer to the people that are actually buying the product.
Mm-hmm. Yeah, that's great. Yeah, great. So yeah, we talk about innovation in about today, pretty much. Just wanted to know if you had like some hints to give us about like what would happen in 5 to 10 years. Like, what do you see anything like coming, to the market and really like being like a big revolution, or do you think it's just going to be like small steps by small steps?
So one theme that I think is really exciting, and I hope we'll see more of this in the next few years, but really the buzzword of circular economy. So the idea of manufacturing companies like Saint-Gobain using retired old products to then create their new products, and doing this really kind of across all of our materials. So I think that's very much an exciting theme. And then I think it is pretty kind of incremental on the material improvements. The hope is, I think the hope is that across all our categories, we're finding new technologies and new approaches and driving or improving performance on all of them. But the large overarching theme, I think, of circular economy is really something that's prioritized across companies.
Mm-hmm. Yep. KP, yeah.
Yeah, I think what I'm excited about is I think we're continuing to bring tool sets, whether it's software, hardware, or whatever, to people that are very creative, right? And the thing is, like, we can talk about technology and innovation, but when you look at like application and use case, that happens from individuals, like creativity of, oh, how do I use this recycled fabric to turn it into luggage? How do I, that interesting creative thinking. The challenge is always like, how do I get scale? How do I have some companies actually in the apparel industry that my family office invests in. And it's really interesting to see how people are thinking about recycled clothes and what can I use it for? And those ideas are fantastic. And I think in the past, executing it was very hard. Buying a robot was $1 million. You can now buy sorting robots for $50,000, for $10,000. You can buy computer vision. It's called buying an iPhone, right? It has built-in LiDAR, and the next version of the next version, someone showed me an app where like Lego deployed, you can throw all the Legos on the ground and it automatically identifies all the Legos and what you can build with it. And that's free, right? That's insane. So I think if we can give these technologies and tools to people that are super, super creative, I think it's like limitless. And that's what's exciting for me.
Yeah, it sounds exciting. Definitely. Great. So just wanted to finish on this topic. I wanted to have your opinion and your vision on what happened during the pandemic, of course. So what can you say has changed during the pandemic, or did you see any change at all? Ben, yeah?
Yeah. So a number of things, I would say. So one, I think, so a focus on renovations, a focus on flexibility in spaces, a focus on kind of well-being and health in spaces, whether that's in the home or in offices or in on automotives and transportation. And so I think those are all themes. And then really just, I think, driving a lot of the issues or topics facing this industry to more so to the forefront, where kind of further driving this need for innovation, increase in productivity, because with the past couple of years, it's led to these supply shortages. It's led to increased labor shortages, and so I think if anything, it's elevated the need for innovation and for companies to work with startups and to bring in new ideas and different approaches. So kind of the combination of those things, which to me is an overall kind of boost in construction tech, prop tech, materials tech in general.
Yeah. I think for me, the biggest thing I've seen has been kind of a wake-up call at a very human level. Like at a very human level, I have seen real estate developers that never really cared. They just cared about money. All of a sudden saying, you know what, I can make money. There's nothing wrong with making money. It's a great thing. I'd rather have more money than less money. That's how money works, right? But can I make more money and still do things that I can be proud of? Not proud of externally, but internally. Like, can I actually feel proud of my work? And I think that's unlocked a thinking away from just doing what I've always done. I have construction companies saying, KP, we really care about job site safety. And I'm like, really? Are you worried about your insurance? They're like, no, we're worried about people. Pre-pandemic, it would have been, oh, I'm worried about my insurance policy. And I think there's this human engagement that's happened with people where I care about job site safety because I don't want people to get hurt, not because I want my insurance premiums to be lower. And I think that shifting and thinking at the executive level, I think executives have been given permission to think more than just the bottom line. And I think a lot of people needed permission to do that.
Interesting, yeah. And on another level, you talked about like the question of like producing local or have everything local, and we actually saw with this pandemic that like construction companies have like reported shortage because of that, and like home buying has declined, like so regarding like really the construction industry, like how did that like been affected by this pandemic?
Yeah, I mean, I think supply chain issues are a problem, right? Everybody's worried, and what people don't realize is most in construction specifically, the supply chain is very malleable. It's the surges that are the problem, right? So what if it's kind of like the toilet paper shortage, right? There was a toilet paper shortage for a period of time. Then there's not a shortage, right? These supply chains and manufacturing supply chains are very adaptable. It's just that when you say stop doing everything for 90 days and now start up again, and I need all the demand from now as well as the last 90 days, it's impossible to surge, right? It's very difficult for them to surge. So I think a lot of what we're seeing right now has to do with that surge demand, which over time starts to normalize a little bit. But I think the other thing is that's, the affordability of houses. I have a thesis, I came out of retirement to start my firm. And, one of my thesis was 20% of all buildings end up in the construction dumpster. Mm-hmm. That is just a fact. Maybe it's more, but at least 20%. So if I told you I could take all that 20% of construction waste and give every human on the planet their own home for free, everyone would sign up for that. So I think for me, a lot of the more waste we can get out of the system will actually keep the cost of housing and buildings lower. And that's where innovation plays a role to drive that level of affordability. And I think we'll start to see it. I mean, we're dealing with a surge situation right now. I think the surge will normalize.
Okay. We hope so. Ben,
well, it's math. It's math. It's math.
Completely agree. And we've definitely seen that. It's a very all hands on deck situation across manufacturing plants globally. But it's I think as things normalize, then it's more thought goes into how do you prepare for this next time? How do you improve and really kind of how to increase efficiencies and improve for future situations like this or high demand spike periods.
Yeah, definitely. Great. Very, very interesting. Thank you very much. Time flies, so we have to get to the next session. I just saw a question from Benjamin on the chat. We pretty much answered it. He said, "What is the current biggest trend in new building materials?" But he was asking about carbon sequestration or composites, concretes. Anyone wants to answer that?
Yeah, I mean, I think we're seeing all of those things. But what I would say is all of those things have existed for 15 or 20 years. Hybrid composite decking, using different materials of different fibers, different additives. Now you're seeing companies like Carbon Cure. You're seeing it definitely in the precast world. Concrete in place is tracking a little bit differently. I don't think there is one trend. I think some of if you're tracking CLT, cross-laminated timber, very interesting, very counterintuitive. That if we cut down more trees, it's good for the environment is very counterintuitive. But it actually is true that CLT is actually better from a carbon perspective than concrete. So you're starting to see some things there. My initial reaction to CLT was, I don't think that makes sense. But I'm also a person that is very unsure about EV strategy because I'm not sure what we're doing with all these batteries. Like, I don't, what are we doing with all these Tesla batteries? What are we doing? I don't know. And they're terrible. They're poison, right? So I don't know.
Great. Ben, did you want to add a word or?
No, I'd say I agree. Kind of themes across all of those, which it's our hope is to keep seeing and meeting with these companies and hopefully that will lead to getting their innovations mass produced, manufactured, and used instead of the less sustainable versions.
Yeah, great. Thank you so much, Ben, KP, for your insight. Thank you again for accepting my invitation. Please stay with us for the second part of the presentation.
All right.
Great. Thanks a lot.
Bye-bye.
Okay.
Great. So we're going to start the presentation. So we're going to have 5 today. The first one will be James Cheryl. There we go. All right. James Cheryl, if you can join me on stage. Hey, how you doing?
Good morning. I'm doing well.
Great. Perfect. So presentation for general graphene, and the floor is yours.
Fantastic. Thank you. Well, good morning, everyone. My name is James Sherrill, and I am President and CEO of General Graphene. Because this is a new materials conference, I'm not going to go into the details about what graphene actually is, but I'll give you just a little update. Graphene is a two-dimensional form of carbon. It has many of the world's first. It's up to a couple hundred times stronger than steel, has 1,000 times better electron mobility than copper. It actually is 20 times more heat conductive than the best known heat conductor in the world, and that was diamond. So it's got a large number of firsts associated with it, but it has kind of one problem. It also ended up being one of the most expensive materials to make on the planet. In fact, my partner and I used to joke about graphene is that the only thing more expensive than graphene was antimatter. Believe it or not, that was actually true for a while. So in short, our passion at General Graphene is to bring industrial scale, large scale production of graphene to the world. Very, very simple. Now, do I click the slides or do you? I guess I do. Okay, so let me back up one. So a quick company snapshot. We were founded in 2014, and we spent the first 3 years developing our process and technology. And then in 2018, late 2018, we secured $21.7 million of financing to develop our current generation of production facilities for graphene. We have about 25 employees now. We're scheduled to have about 7 more by the end of the year. We have 3 issued patents, 9 pending, and more than a dozen in the works. And we have more than 30 customers, the vast majority of which are international. Interesting enough, about 10 of these are even in the last several months as we've been actually getting the word about General Graphene out. Now, I'm going to give you a really quick pitch that I gave back in 2018, and you can tell me what's wrong with my pitch. We're going to do something nobody's done before. We're going to do it in volumes that the Nobel Prize winner says can't be done. And we're going to do it for markets that don't exist. And we need $20 million. So you can see that probably didn't get me very far in the beginning. However, the reality is once we were able to show people what we could do, it actually did. So if I have one thing I want you to remember today about our technology is that we've been able to reduce the cost of graphene by more than 1,000 times. When we first started 2014, the cost of graphene was more than $100,000 per square meter. It could do everything in the world in the laboratory except leave the laboratory. Our current technology puts our cost of graphene well under $100, closer to about 20. And that's in volume. And what's really interesting with our newest generation production machine, we are just starting. So they say a picture is worth 1,000 words, and it really is. This is our 3rd generation scalable roll-to-roll graphene pilot production. This machine can produce on the order of 300 square meters of graphene per day to 50 square meters of graphene, depending on the application. And of course, like just about everything else, not one size fits all. Graphene, we can produce different graphene for different types of production. Well, now that may not sound like a lot, 300 square meters a day. You have to remember this machine is really just it's the beginning of the 3rd generation, and we could easily produce 1 million square meters plus in the current facility that we have. The last part about this is notice that it is composed of identical sections. Every bit of this is full custom, fully designed by ourselves with a tremendous amount of IP and intellectual secret sauce associated with it. But this was our first production machine that we are actually now producing graphene for other companies. I'm going to end with, and there's a very short presentation, again, I am the president and CEO. We actually are very well funded. We're in really good shape. We have a lot of customers, and we're growing somewhat exponentially. And we are looking for companies that would be interested in using our graphene. Our graphene can be used from everything from barrier films to Band-Aids to pharmaceutical products to anti-corrosion coatings to proton barriers. There's just a tremendous number of properties it could be used with, and we are entertaining customers as we speak. That's it. Thank you very much. And if you have any questions, please get a hold of me at the end.
Great. Thank you so much. Thank you so much, James. And we're going to move on with the second presentation with Paige. So Paige, if you can join us on stage. Just waiting for Paige.
We are. Apologies about that. A bit of technical difficulty joining. Wait, you can hear me now, Florian.
Yes.
All right.
Thank you so much, Paige.
Thank you. And thanks to our host and to the keynote speakers for what was a really interesting discussion in an area of the construction industry that I really know little about. And so I'm going to kind of adjust my pitch a little bit to, I think, maybe respond to some of the broad themes that I think all of us are interested in here about, kind of how you develop new materials, how you bring them some materials to the marketplace. We're working in the area of battery materials, where we really have a twofold mission to develop and deliver not only the world's longest lasting battery materials, so highly energetic materials that last longer than normal battery lifetimes, but that also are fundamentally sustainable. And that was a part of the very beginning of our business model, that we would only work in sustainable places. And I think one of the interesting things to me as I founded a materials company in 2014 and have sought to take that forward especially in the US, there's a lot of greenwashing about material innovations, about even things like KP mentioned about the concern over what's going to happen to these batteries after they're in the EVs. There's a lot of kind of, I think, trying to paper a layer of green and sustainability over existing technologies. And I think we started from a position that we would only work in low toxicity and abundant areas of the periodic table. I'm a chemist, and so I think of things fundamentally on an atomistic and material basis. And so I just made the decision when I founded the company that we would only work in what I see as the friendly portions of the periodic table. There was just so much interesting chemistry to be done there, and so much scope for the imagination, and that I felt like there was no reason to work at anything that was not sustainable. And that fundamentally we would value the practical and scalable over the exotic and heroic. I left the university to found the company. University research is generally predicated on heroic effort, and that's exactly what you don't want. To make something that will actually reach the market. You want to work with something that's sustainable, direct, and straightforward, and that's what we did. And I think we've been really successful in getting there over the last 7 years. Fundamentally, to make better batteries, we need better materials. It can be difficult enough to get people that maybe use a cell phone to think about the fact that the important part of their cell phone is actually the battery that runs it. It can be even more difficult to get them to realize that the important part about the battery are the materials inside it, and that's the chemicals inside the battery that create chemical reactions, that undergo chemical reactions, that actually create electrons that can move through the external circuits and make the phone or the car or whatever it is do their work. Those materials actually have the highest margins in the battery value chain. So from an investment standpoint, they're an excellent place to consider and to work in. They're expected to grow at the kind of CAGR of the EV market in general, at a 14% CAGR, reaching $75 billion in 2027. So an excellent opportunity, but also the place that change really has to happen for batteries to improve. And the battery has three main parts: anode, electrolyte, and cathode. You probably have seen a lot in the news about companies working on the anode side, adding silicon to the anode to make it more energetic. Also on the electrolyte side, moving from liquid electrolytes to solid state electrolytes to make them more safer. But we are actually working on the cathode side. So we're working kind of in a neglected portion of the battery chemistry to really revolutionize and transform it. And what I want you to take away from this is that we are not asking too much of our batteries. We are asking too little, and that parity with fossil fuels is possible. The first principles problem of battery materials is that not as many atoms are engaged in the reactions as are engaged in combustion. If I burn a bit of gasoline, all those atoms give me back my energy. In the lithium-ion battery, only 5% of those atoms in the lithium-ion battery are actually doing the work that makes your car run. And so that's our focus, is to just increase the number of atoms involved in these electrochemical reactions. That's given us really broad space in the patent. We've been given large patent coverage for a new class of high energy battery materials, 7 patents granted, just got our first international patent recently, 61 national and international patent filings in process. And uniquely, we have a 2-tiered business strategy in which we want to affect all batteries. All batteries impact the climate. Now, everybody talks about the EV battery and the need to move to EVs to reduce our carbon footprint and save the world. But 75% of the batteries sold are actually batteries that are used once and thrown away. They are still the type of portable energy storage touched by the most people, the most often. They're essential to the needs of the developing world, and we care about them too. And if we could adopt a double lifetime single-use battery, which we have demonstrated globally, that would be the equivalent to removing 1.3 ICE engine vehicles from the road every year. I think the relevance perhaps of this to the construction industry that we've just talked about is this is really the Internet of Things space, right? These are the things that we want to add to buildings, that monitor them in different ways, that monitor their use patterns, that add to building management, that make that easier and more labor-free, and making these batteries now reach the lifetime of the sensor applications. It's essentially a forever application for the Internet of Things. And that's a single-use battery application most often still, not a rechargeable application. So we've reached really implementation stage in our single-use business battery strategy, are very close to signing an agreement with a major battery manufacturer for implementation of our trademarked 10X material into their single-use batteries, and are currently engaged in shifting our development focus to the rechargeable space, where every gram that substitutes in a cell for an existing material contains no cobalt or nickel and is sustainably and domestically produced. And also relevant to the recycling discussion, we have the ability to first closed loop recycling. That's not currently implemented in our production process, but we plan to start production from recycled materials in 2025. Uniquely, in terms of these fast scaling discussions that we had earlier from our keynote speakers, we're already at tonnage scale. So we are even now about a mile away from where I'm sitting, testing out the industrial controls for our 12-ton annual production capacity facility. We will be the world's first net zero carbon footprint facility. I was really interested to hear you all talk about the needs in construction. We just, as an individual decision, reused an old town building that was lumber and concrete block. As we had to remake the building, we reused the lumber that we took from parts of the building and building other parts of the building, and the concrete block as well. So that was just an individual commitment that we had to reuse and to not wasting that 20% of the building, as you spoke of, that generally goes into the dumpster. We also have a modular production plan, which translates well to the material world from the construction world, in which $6 million of CapEx builds 100 tons of production capacity that doesn't have to be located under a single roof with me here in Tulsa, Oklahoma, but that can be placed next to a battery manufacturer's plant. And we're currently having our life cycle analysis done by a UK company, and soon we'll be able to kind of stamp that officially that we're the world's first carbon neutral battery materials, largely because we use a much lower temperature profile for production of the materials than is typically used in the cathode industry. So that's where we are, scale to tonnage production, and making that shift in development from the application of our materials in the single-use space, manufacturing and integration there, to moving that development phase into the mobility space. And we're currently raising a $30 million Series B for production and EV market entry. So really pleased to participate in this new materials conference, and open to any questions. Thank you for having me.
Thank you so much, Paige. Amazing technology. Thank you again. And so we're gonna go with the next presentation now. So Cora, yeah, can you join me on stage?
Here we are. And do you have the slides, or should I share? Yes, very good. Thank you. Thank you for the invitation to present. I apologize that I'm presenting from the car, but I'm happily visiting some customers here in Germany. So overall, Chromatic 3D Materials, we are a 3D printing company focused on flexible materials and bringing flexibility to industrial consumers. So I like to say we print with the good stuff. So if you flip to the next slide. So our 3D printing approach is built for the industrial consumer. And what that means is that the 3D printing technologies that have been developed over the last 20 years are great, but unfortunately, many of the materials that are available to be used do not compete with materials that have been used in industrial practices for decades. So our focus is really to provide industrial consumers with the kinds of shapes they want to be able to print in the materials that they want to print, and to provide the level of versatility that is required in materials for industrial uses. And so, in other words, we're trying to solve a square peg in a round hole problem. Today, there are a lot of fabulous 3D printing technologies. We want to provide the materials and the shapes and the geometries and form factors that are really desired by industrial consumers to really help drive the growth of 3D printing into industrial markets. So if you move to the next slide. Our team is one that's based in Minneapolis and in Germany. We have 12 people split between chemistry and additive manufacturing and software. And many of us come from the materials industry, and we really understand what drives material selection and why among industrial consumers. Our headquarters are in Minnesota. If you go to the next slide, please. So the problem that we're solving, and the problem that 3D printing has the potential to solve if we can provide materials that can really perform in industrial applications, is one of the global supply chain. And really we call this the global supply chain insanity. So the problem that we have, and the reason why we have so many supply chain problems that pop up with accidents like, you know, a barge getting stuck in the Suez Canal, is that global mass production is really cheap. So when you have specializations that occur around the world where an individual company is able to make one widget really, really well, and then they ship it around the world, this can be very low cost. And that's what we've gotten to. But the problem is that when that gets disrupted, the repercussions are really felt throughout the world. And so what 3D printing can enable is a method of low cost, small volume production. And what that allows is for the production of parts where you want it, when you want it. And that's really what 3D printing can bring to the table, but only if the materials are made from the kinds of materials that are desired in the in manufactured goods. So if you go to the next slide. So one of our customers, just to demonstrate this point, one of our customers has been Deutsche Bahn, the German rail service. And they started a search looking for a 3D printing technology that could solve their problem. And they had basically a supply chain problem. And this is something that we hear about from our customers every day. So Deutsche Bahn wanted to produce this very simple part, you know, and it looks very simple, and you'd say, of course 3D printing can produce this. The problem that they have is that they need more than 300 dimensional variations of this part to keep their trains running. And the problem is that they've got trains that are, you know, been on the rails for 60 years or more. They all need very different shapes or dimensions for this part. It goes in the brake system, and it has to seal against air pressure. This is a great opportunity for 3D printing because oftentimes the amount that they need of a given geometry, of a given dimension, is only, you know, a few hundred a year. And 3D printing is able to have much more competitive costs when you're competing at 3,000 parts a year or less. And so they were facing wait times of more than 6 months sometimes 18 months, because they had small order sizes. And that just made it impossible for them to source. And this is something that it didn't take a Suez Canal problem for them to have these problems. It's very simple in that the companies that make these kinds of parts on a mass production basis simply does not want to stop their production to make a small production lot of 500 parts. So, but this is where a lot of 3D printing technologies are not up to snuff. So Deutsche Bahn had been screening for 3D printing technologies that would suit their needs to be able to print this very simple part for 5 years. They screened more than 15 different technologies. Only Chromatic was able to pass the basic requirements of being able to seal against air pressure on a repetitive basis. This alone is a $3 million a year opportunity, and that extends as you grow to many other rail companies around the world. They all have this problem. So we can go to the next slide. So our focus is really in the spare parts market. PricewaterhouseCoopers predicts that by 2025, 25% of all spare parts will be 3D printed because they meet the specification of needing fewer than 3,000 a year. Just looking at flexible materials, the market is $12 billion of elastomeric seals and gaskets. And so taking that 25% figure, that's a $2 to $3 billion addressable market for low volume replacements. The European rail serviceable market alone, so when we get all of the qualification requirements for Deutsche Bahn passed, and we're well on our way to do that, that's just a $90 million market right there. And industrial 3D printing overall is projected to grow from its state of $15 to $20 billion to $120 billion just in the next few years. So next slide. So some of the examples of customers that we're working with besides Deutsche Bahn include the US Navy, working with companies for doing remote part distribution, also a number of customers in textile printing, where you can start to get different forms by applying the 3D printing technology on top of textiles. So these are just some of the applications that we're pursuing. Next slide. And the secret sauce of what we have is really built into the proprietary resin as well as software. So we have 2 issued US patents. We have 8 patent families in total going through global prosecution. If you were to take a standard material, a standard urethane that's bought on industrially today and used industrially today, and put it in a 3D printer, you'd get like that blob that you see in the top left there. Applying our chemistry approach, we're able to take that kind of material and make it stand up so it's printable. So we really take industrial grade materials and turn them into printable materials. And that's really the core of our technology. Furthermore, if you tried to print with our materials with a standard printer using standard software, you really get a messy print like you get on the lower left. And we bring a lot of software development that allows us to have high quality prints with our resins. So we really bring that combination of software and resin. And all of that is claimed along with the printing methods in our proprietary technology. So the next slide. So we're working on a $5 million Series B. We're having our initial close really imminently in the next few days. Our lead investor is Embedded Ventures. The syndicate is put together, and but we still have some openings if people are interested. The prior investments to date have been $4.5 million coming from a combination of a National Science Foundation grant, equity, as well as convertible debt. And really what we're going to do with the Series B is expand the team, ramp up our operations and sales, and then also continue our technology development to continue to get faster, better, and stronger. So overall, we really want to help our industrial customers innovate with our technology and 3D printing. And I look forward to answering any questions. Thank you.
Cora. That was very, very interesting technology. We're going to move on and see the presentation of Ravish. Thank you, Cora. Bye-bye.
Bye.
All right, Ravish, if you can join me on stage. Great. All right, Ravish, perfect. Thank you so much. The floor is yours, and you can share your screen.
Thank you very much. Thanks very much for the invitation. Please allow me to share my screen here. Hopefully you guys can see it.
Yes, that's perfect.
Awesome. So my name is Ravish Majidia. I come to you from Boston, Massachusetts. And we are in this space, Magnomer is in the space of advanced materials, specifically in the area of printable magnetic inks. So very different in construction, but a lot of you may be aware of the news that percolates each and every day around the lack of plastics recycling. There have been tremendous efforts globally, including regulation both here in the US as well as in the EU, where public consumer brands are being pushed to increase the amount of recycled content and therefore increase the overall sustainability of single-use plastics. The chart here on the right, or the metric here on the right, is just the current status of where things stand. PET, which is polyethylene terephthalate, is the most common form of plastic used in all beverage bottles, and type 1 plastic, it's what it's commonly known as. And the current global supply of recycled PET, or rPET as it's more commonly known, stands at only about 10%. This is woefully short of what is the public commitment by consumer brands such as Nestle, Coca-Cola, Danone, PepsiCo, and so on, which have all of whom have committed to use at least 25% recycled content in their beverage packaging by the year 2025. And even for looking forward, EU laws mandate at least 50% recycled content by the year 2030. Similar law is on the books here in the US in the state of California. So long story short, we are in kind of a crisis mode when it comes to plastic recycling, where there is not enough recycled content to go around, even for packaging categories or plastic categories that are known to be very highly recyclable. One of the big reasons why this is occurring today in the industry is that the packaging that is put out is just simply not designed for sorting and not designed for recycling. Packaging often consists of multiple different components. Shown here in the left is a simple beverage bottle. All beverage bottles, as you probably know, have a label on them. And the bottle plastic, which is typically made up of PET type 1 plastic, differs from the label. There are a variety of operational, marketing, and supply chain reasons why this happens. But it is these labels that which commingle in the plastics recycling process that reduce the overall yield of recycling and the overall quality of the recyclate at the end of the process. Thus, the separation of these packaging elements, such as separating the label away from the bottle, is a very crucial aspect in increasing the overall recycling yields as we look forward. Sorting the label away from the bottle is complex and is more difficult than it meets the eye. And this is kind of where Magnomer really helps. As I said at the top, Magnomer is commercializing a magnetic or a magnetizable ink technology, which is printable on all kinds of plastic packaging. It can be printed on things like bottle labels all the way to multi-layer packaging. Our big value proposition to the consumer brands and packaging manufacturers is a seamless integration on current packaging designs, where our inks can be printed using current flexographic or gravure printing technologies. By the virtue of it being magnetic, recyclers can now simply magnetically eliminate the undesirable labels away from the bottle, and therefore increasing recycling yields for the package that is currently collected. Some of quick facts about the ink, Magmark ink technology platform. It's a patent pending technology where we really focus on the design of the ink from two different prospects. One is from the consumer brand and the packaging manufacturers. Our inks are drop-in inks in the sense that they can be used during current package printing. They behave no differently than any other color, for example, a red, blue, green color that is printed on a label on a bottle. And importantly, the inks can be made transparent, which is a very important element of our technology. If you look at the labels here, the one on the top has a standard pink and white color, but the one on the bottom has our Magmark SS coating, which is a transparent magnetic coating applied on the entirety of the label. The ability to make our magnetic ink transparent, or the magnetic coating transparent, really allows the packaging manufacturer and therefore the consumer brand to integrate this sortability feature via magnetic ink without any change to the overall look feel of the packaging or any change of the overall design or the functionality of the package itself. Most of all, the other way we design our inks is we look at the recycling technology out there and understand what magnetic separation equipment already exists in the current recycling industry. Magnetic separators have been used in plastics recycling for multiple decades now. So our inks are really designed to complement that magnetic separation, those magnetic separators rather, and allow the ability for the recycler to simply magnetically sort out these undesirable labels using the equipment that currently exists in the market. The combination of these two means that we have a very scalable technology on the manufacturing side, which can deliver a sortability and impact the overall recycling yields globally using the current infrastructure already in place. Our Magmark inks can be applied across a variety of different packaging verticals and packaging formats. They range from things like shrink sleeves, which are used for energy drinks such as Gatorade and Powerade, all the way to things like shampoo bottles and detergent bottles, the labels of which are also a problem in recycling, and multi-layer flexible packaging such as your potato chip bags. Across all these packaging formats, there is one common issue, and that is the inability to economically sort in the industry. Our magnetic inks printed alongside printing current inks allow that ability to sort and is scalable in a way that it can increase recycling yields by eliminating undesirable packaging elements. A good example of this is, as I said, our Magmark SS inks, which are inks designed for shrink sleeves specifically. These inks have been shown with customers such as PepsiCo to be printed on a commercial scale, where we have printed multiple square kilometers of inks onto existing packaging SKUs, and have been shown in commercial recycling facilities to eliminate these shrink sleeve labels at efficiencies of over 99.5%. We are effectively eliminating a problem packaging category, which is a shrink sleeve label, from PET bottle recycling, all by the simple addition of a magnetic coating during the printing process of the label. This technology is something that has been it's already patent pending and has been recognized by the Association of Plastic Recyclers here in the US. The APR, or the Association of Plastic Recyclers, is an influential organization which sets design guidelines for plastics packaging. Magnomer is achieving the APR Responsible Innovation certification alongside our customers PepsiCo and label manufacturers such as Fuji Seal. This triumvirate of stakeholders in the industry goes to show the efficacy and the importance that such sorting and the value proposition that the Magnomer ink technology brings to the market. And so to recap, Magnomer is introducing realistically a new category of inks into the packaging market, enabling a circular economy and enabling a more sustainable value chain for recyclable plastics. And with that, I'd like to close off, and thank you very much.
Thank you so much, Ravish. It was a pleasure to welcome you. We're gonna end the presentation with Alex for the last presentation. So Alex, if you can join me on stage. Great. Yeah, Alex, are you here? Just waiting for Alex. All right, seems like Alex has some technical difficulties. So we will go on, unfortunately. So I'm going to go ahead and close this presentation. So just wanted to, before ending the presentation, just wanted to give you like a hint about the next tech meeting. Will be on October 12th around circular economy, and I will see you soon.
Hello, guys. Can you hear me?
All right, Alex, are you available for the presentation?
I am. Yeah, I've been having trouble unmuting. The app isn't working exactly correctly.
All right, perfect. So I'm gonna come back on you, and I'm gonna share the presentation, and you can go ahead.
Excellent. All right. Hi, everyone, and I apologize for coming to you from the car. My name is Alex Blum. I'm co-founder of Applied Bioplastics. So let's start by talking about the economic expansion driven by durable plastics over the last century. Planes, trains, and automobiles, toys, tools, and technology, all cheaper, lighter, more accessible to more people. Next slide, please. Plastic is an amazing invention, and that's why, even though it's already everywhere, demand for plastic is still growing faster than the expansion of the human race. Next slide, please. In 2015, plastic production accounted for 1.8 billion metric tons of CO2 emissions. If projections hold, emissions will reach 6.5 billion metric tons per year by 2050, over 15% of the total human carbon budget. Next slide, please. Of particular concern are durable polymers, which make up over half of all plastic produced annually. Yet, most alternatives are focused on the plastic waste problem, primarily reducing single-use plastics like LDPE and PET with expensive and biodegradable alternatives, which we're a huge fan of, but which also leaves a major hole in the sustainable plastics market. Next slide, please. At Applied Bioplastics, what we do is we make bioplastics for durable goods manufacturers that are cost competitive, mechanically identical, globally scalable, and most importantly, vastly reduce net carbon emissions. Next slide, please. We do this in several ways: reduction of petrochemical inputs, carbon sequestration in the soil, carbon sequestration within our durable composites, and by diverting waste biomass from being burned and composted. We're able to compete directly with legacy plastics on price because we use abundant, renewable, and most importantly, inexpensive and globally available plant material. This is possible because we have achieved a major breakthrough in cellulose processing. Next slide, please. A low capex proprietary technology that allows us to use cellulose from nearly any kind of fast-growing fibrous biomass, which is revolutionary. Anything from processed hemp to agricultural waste to lawn clippings. We'll take it all and turn it into usable, valuable plastic composites. Next slide, please. In the last 2 years, we've secured our IP, competed in and won several well-known business competitions, including at South by Southwest and Mass Challenge, built a team of 20, and begun acceptance testing with some of the world's largest manufacturers. Next slide, please. At scale, we'll be reducing the CO2 output of manufacturing by hundreds of millions of metric tons, and further product improvements like using recycled or ocean-recovered plastic will push those gains even higher. Next slide, please. Better yet, we'll be meeting multiple UN SDGs by empowering rural communities and emerging economies by purchasing both farmed fiber and agricultural waste at fair trade prices. Next slide, please. We're confident in our success because our process and our products were built from the ground up to be drop-in replacements for both feedstock manufacturers and their customers. We use the same industry standard machines to produce our plastic pellets as everyone else, the twin screw extruder at the top of your screen, and the temperature, timing, and equipment for their use by our customers doesn't change at all. Several of our prospects are currently engaged in acceptance testing without making any changes to their typical production lines, and when they're finished, we'll have proven that rapid global adoption of our plastic alternative is an achievable goal this decade. Next slide, please. We're engaged with half a dozen manufacturers in the Fortune 20, as well as with several other household names responsible for big chunks of the total plastic manufactured annually. By 2030, we plan on delivering nearly 5 million metric tons and helping manufacturers avoid over 4 million metric tons of carbon emissions. Next slide, please. Out of a total annual addressable market starting at 120 million metric tons, and this is only polypropylene, our first product, we do expect to claim a 1.5% share by 2025. Delivering on that market share allows us to generate significant profit rapidly. Over 5 years, we'll accumulate over $230 million and be generating over $130 million in profit annually. And that's before we get to other materials. We are working on a joint development agreement to create a PVC composite using the same technology, and we are definitely looking for new partners now and today, looking for other polymers that our platform can be extended to. Next slide, please. Our strongest asset beyond our intellectual property is our team, with a century and a half of experience in plastic, 5 PhDs, experienced business and sales leaders, and of course, what every good startup needs, a bunch of talented youngsters dying to make a difference. We know that what starts here is going to change the world of manufacturing. Next slide, please. After 2 years of work, we're months away from capturing our first revenue from some of the largest brands on the planet. Supplying only 2 to 3 of these customers can bring us to that 1.5% market share within 5 years, which equates to that $230 million in annual revenue. We've just finished launching raising our launch round, and are currently completing a Series A with the help of several strategics as well as financial VCs. If you are interested in participating, please let us know. What we're doing with this Series A is we are validating the unit economics that we've modeled at commercial scale, setting up our first fiber treatment facilities, and scaling to multiple other nations. We hope you'll join us. Thank you for having us.
Thank you so much, Alex. Glad you were able to pitch today. Great. So thank you again. Thank you to all the presenters again today. We had a tremendous time, and I hope to see you soon. And have a great rest of your day. Bye-bye.